Hey class, today we're talking about disjoint and overlapping events. Disjoint is the first term to understand. A disjoint event means that no outcomes are in common. No outcomes in common. Events is plural, so there's two events. Disjoint means nothing in common. For example, I don't know what, there's a crazy glare there. This says, for example, a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a 5 or an ace? So that word or immediately triggers an or problem, means an and, meaning an or problem means we add. Sorry. An or problem means we add, not an and. So you want to think about first, disjoint events means there's nothing in common. So let's go with each one at a time. Well, what's the probability of selecting a 5? That's our first event. So the probability of A is the probability of a 5, and we got to think how many 5s in a standard deck of cards. Well, there are 52 total, but how many are 5? Well, there are 4 5s. Then we want to think about the second event, which is the probability B, is the probability of an ace, which is same total, and we want to think how many aces are there in a standard deck of cards. There are 4, so that would make it 4 out of 52. And then you got to think, is there anything in common? That's the question. A 5 ace, does that exist? Is there such thing as a 5 ace look? Nope, there is no 5 ace. So that means the probability of you selecting a 5 or an ace, either one, we just add them. There are 4 5s in the deck, there are 4 aces in the deck, so that means there are 8 possible answers. Like if we were playing a game and I said, all right, if you get a 5 or an ace, you win. Well, there are 8 out of 52 chances, right? The probability would be then 8 out of 52. So the probability of A or the probability of B, all we do is add those up. So 4 out of 52 plus 4 out of 52 is 8 out of 52, which then reduces to 2/13. That's your answer. So 2 out of 13. Okay. The next thing we're going to talk about is overlapping events. So overlapping, that's an A there, that's kind of blocked off. Terrible. Sorry. Overlapping events, the events have outcomes in common now. So, for example, a card is randomly selected from a standard deck of 52 cards. What's the probability that it is a 5 or a diamond? So, again, or means add. Or means add. So we're going to add these, but there's something different with overlapping. So the first thing to do, again, is same thing. What's the probability of a 5? Well, that's 4 to 52. There are 4 cards that are 5s out of 52 total cards. What about the probability of the second event is a diamond? Well, there are how many diamonds? There are 13 out of 52 diamonds. So then the last thing to think about, is it overlapping? We know it's going to be, but what does that mean? That means there's such a thing as a 5 diamond. There's such a thing as a 5 diamond. And that's what you have to ask yourself to know whether you're doing this. So that means there was a 5 diamond out of these 4. And there was a 5 diamond out of these 13. So we added up the same card twice. So we have to think about what that is, the probability of A and B. So a 5 diamond, there's one card that's a 5 diamond out of 52 total cards. Now, the formula is very similar. Before we just added those numbers up. Well, now we are going to add up A and B, but we're taking away that extra. So we have the probability of A or B equals the probability of A plus probability of B minus the probability of A and B. So I have 4 out of 52 for my 5. I've got plus 13 out of 52 for my diamonds. And then I've got minus 1 out of 52 for my both C's, the and. And so then I have 4 plus 13 is 17, minus 1 is 16 out of 52, which then I reduce to 4/13. Yay! Whoa, almost died. Not trying to die today. Nope, nope, nope. Okay. Last thing to learn about is complementary events, and they are two events that the probabilities add up to 1. So this is probably the quickest math out of all of them, I'd say. For example, the probability of A, let's say it's a fraction 1 out of 5. We have to remember that that 1 out of 5 is the favorable out of our total. So the probability of not A is 4 out of 5. Because if our total is 5 and there's 1 favorable, well then how many are left? Well then there are 4 out of 5. So if this says probability of A equals 1/5, then the probability of not A equals 4/5. So same thing if you have a decimal, the probability of A is 36.36, then the probability of not A is 0.64 because these two numbers add up to 1. So you do 1 minus 0.36. Or you think if this is out of 1 total, like 36%, what's left? 64%. Well, that's 0.64. All right, and these are the kind of questions I'm going to expect you to know. For example, when 2 number cubes are rolled. I think that's when I almost died. I knocked that. When 2 number cubes are rolled, find the probability that the sum is greater than 3. Well, the sum is greater than 3. That's more numbers than not the sum is greater than 3. So it's easier to think about those. So like first thing could be my smallest amount could be a 1 and a 1, right? The first number cube says 1, the second number cube says 1. So then I have 1 plus 1 is 2. Then 1, 2, 1 plus 2 is 3. Then 1, 3 is 4 when I add those numbers up. So that doesn't count. So then I go to 2, 1. 2 plus 1 is 3. That counts. 2, 2, that's 4. Doesn't count. Then I went to 3, 1, which is 4, doesn't count. So I know all of these numbers. I don't have to list them. I know all of them are going to be greater than 3. So I'm looking for what's not greater than 3. Well, how many are there? 1, 2, 3 out of 36 total outcomes. So 3 out of 36 is not what I'm looking for. So I think about the opposite. The complement of it would be 1 minus 3 out of 36, which is 33 out of 36. And that's 11 out of 12. And that's our lesson. Cool. Disjoint and overlapping events are all about the or scenarios. So that's what you want to think about. Yay.